Hey there. Last time we created a GET request that reads the blockchain data from the running application. Now let's make a POST request that will allow someone to add a new block to the chain through HTTP. A POST request allows the requester to submit data to the API and application. And based on that submitted data, new objects can be created based on application logic. So let's configure a POST request to mine a new block to the chain. Like the .get method on this app object, there is a .post method that Express provides for us. So let's add .post on the app. And similarly, the first argument is the endpoint. So let's make an endpoint of /API/mine. And then it has the same callback function. And this callback function has the rec and the res parameter as well to represent the request and response object as part of the overall request. So this POST request is going to receive data from the user in a JSON format. Within the request, they'll specify a JSON body field that includes the new data for a block to add to the chain. Now this puts the request object into play. We didn't use it last time, but we're going to use it now. And this is going to contain a body field, which contains the very data that the requester wants to add to the blockchain. So that is accessible in request.body. And we want to destructure the data field that is contained within this. So let's destructure the data in rec.body. Cool. Now that we have the data, we have what we need in order to add a block to the local blockchain instance. So we can call blockchain.addBlock and will consist of an object that has the data field found in the request body. All right, great. This will add a new block with the data from the requester. Now let's give the requester some confirmation that their request was successful. It would be nice to see if their new block was added to the chain. Luckily, we already have an existing endpoint which renders the blockchain data through HTTP. Therefore, as the result of this /mine request, we can redirect to the existing /API/blocks endpoint. We'll call res.redirect and we'll send them to the local /API/blocks endpoint. So the result of making a POST request is that you'll receive the same blockchain.chain JSON from the API/blocks GET request, except you'll see that your new add block data has been added to the blockchain instance. Cool. So that completes the new POST request. However, before we test it out, there's one piece to Express that we still need to add. Currently, the Express application is not configured to be able to receive JSON just yet. To do this, we're going to need to add a piece of middleware to Express. For now, you can think of middleware as enhancements to the Express application that give each Express request a little more functionality by running some methods. In this case, we're going to install a piece of middleware called Body Parser, and this allows the Express application to parse JSON bodies in requests. So head to the command line, and then we want to install the body-parser module. And in this tutorial, if you want your project to be compatible, install the version at 1.18.3. And then use the save flag because this is a dependency for the overall project. Then we want to head to the index.js file, and then we want to get body parser, and this is the result of requiring the body parser module. And notice that the body parser name is camel cased, while the module name has a dash. Now we can tell Express to use some middleware that has been contained within this body parser module. To use that, we literally use the app.use function. And there is a bodyparser.json middleware function that we can use that is contained within the body parser module. So with that configured, let's test out the new /mine request. First up, we're going to start up the entire application, but let's do it in dev mode by firing our npm run dev command. So in dev mode, we'll use npm run dev. And as we do so, nodemon fires the index.js file. And notice that nodemon has been configured to restart at any time with a save, and it's watching everything from the root. And by default, it's firing that node index.js command. So nodemon will refire node index.js every time we make a change. Cool. The next step is to actually test out this new post request. To conduct a post request, we'll need a method with more options than entering a URL in the browser, because that makes a GET request. Now, normally using the curl tool on the command line is a great option. However, since it's not immediately available on Windows without extra downloads and some modification, a better option for cross-environment is the Postman Developer tool. So likely you installed the tool along with the other software during the requirements article at the beginning of this course. But not to worry, if you don't already have Postman installed, go ahead and look up download Postman in the browser, and it has some great, easy to follow instructions right there on its own webpage. You can also visit the software requirements section at the beginning of this course to find those similar directions. All right, so I'll go ahead and open up Postman now. And here we are with Postman. And once you have it open, you should see a window very similar to this. So we want to configure a post request. The first thing that we want to change is the type of request to post instead of GET. And we're going to be hitting http://localhost port 3000/API/mine. Very nice. The next thing that we want to do is we want to go to the body tab. We want to select raw and then application.json, or rather application/JSON as our body type. Now let's configure some data. And then this has to be JSON, so the key of the data is with double quotes surrounding it. So make sure you have those double quotes. And then we have foo data as the value for this. So this can be anything, but foo data works just fine as a dummy value. Notice that by requesting, or rather selecting application/JSON, we get this headers field where the content type has been set to application/JSON for the actual web HTTP post request. All right, cool. So once you have all of that configured, you're ready to click the giant send button. And as we do so, we get a response. And the response is a big blockchain. First, it's the Genesis block, and then it's a second block that contains our new data in the actual response. Now, it's not immediately obvious, but Postman is doing some extra work on our behalf. Normally, when a request results in a redirect like we configured, you only get a message that the request has succeeded and that you have to follow this other redirected endpoint. But Postman is configured to follow redirects by default and make an extra request for that redirected endpoint on our behalf. So to see the normal response of a redirect, we can adjust the Postman settings. There's this tool icon over here with this red dot. Notice that there is this option to automatically follow redirects. Well, let's turn this off. And as we do so, when we click send again, this time the response is found, redirecting to /API/blocks. So if we were to create a front end and then make this post request, this is the response that we'd automatically see. And then it'd be our job to make a GET request to localhost API/blocks. So let's do that. We're gonna go to localhost 3000/API/blocks with a GET request. And what we should find now is that there are in fact 3 blocks in the overall blockchain. So thanks to Postman, we don't have to do this extra work while developing with the Postman tool. It's a very convenient option, so let's turn it back on. But it's something definitely to see, since you might be confused why you're getting this alternate response from Postman when you make that request in an actual front end that you create. Cool. So with that, we've completed a new post request to mine a block of data. And this completes the basic API functionality for interacting with the blockchain. We have a way to read the blockchain through a request, and now we can add new blocks to it through a request. Next up, let's add a huge feature, the real-time network. This will get multiple blockchains to interact with each other on a more immediate scale than making HTTP requests to read each other's data. So instead of constantly pinging each other, we're going to have instant feedback between each of the nodes in our blockchain. This is going to be a highly useful feature to make sure that all peers in the blockchain network get notified of blockchain updates and more. So let's get to it.